everyone, welcome to ccqMap.com. Thank you so much for being here. Today I'm going to show you a detailed analysis of vegetation extraction. Without further ado, let's jump into today's topic. Here we have a color infrared aerial image. As you have realized, certain parts of this image are darker than the others. Especially the corners are darker than the central part. This is actually one of the characteristics of aerial images. The brightness difference is mostly dependent on types of aircraft, camera angle, time of the day of the shooting, and etc. The point I want to make here is that not every image is perfect. So we have to make our own observation and adjust our sample points selection accordingly. The objective today is to test if QMap is able to identify and extract different types of vegetation. As you can see in this image, we have two major categories of vegetation, which are trees and paddy field or cropland. First, let's look at the trees. Let's zoom in first. As you can see, most of the trees in this image are located on the mountain. Before we start, we have to make some assumptions and definitions first. In this exercise, we assume the trees in this area of the mountains as type A trees. Because this area is not very dark comparing to the four corners of this image. However, in real life, the identification of certain features from an image has to be done by experts from different industries. This process cannot be done arbitrarily. The experts have to compare and analyze based on visual inspection, experience, field survey, and comparison of different datasets. In this exercise, we can only do simple visual inspection with an arbitrary definition just for the sake of this demonstration. Now we have clarified these underlying facts. We are ready to perform information extraction. Our first objective is to identify and extract all type A trees in this image. Let's start by selecting sample points. Let's click the test button and see if the software can identify type A trees on this mountain. Seems like QMap recognizes most of the trees on this mountain as type A. This makes sense because normally on a mountain, tree types are usually uniform and spread out. But the software didn't pick up trees in shadow such as these areas. That is because the color difference is too significant. Now let me show you something very interesting. Let's move to other parts, such as the building area of this image, and perform the same test based on our selected sample points. We can tell that a trail of trees here are picked up by the software based on previously selected sample points, point 1 to 10. It is highly possible that these trees are the same types as the ones on the mountain, which is type A. To prove my point, we can do a reverse checking here. We can first disable all previously selected sample points from the mountain. We can do that by uncheck the Select All button. Then we will choose some points from the trail of trees which were previously highlighted here, and also this area. Let's do it now. So we have selected points 11 to 20 from the trail of trees which were previously highlighted. And then let's click Test. So now the previously selected trail of trees are captured. Let's move the window to the mountain area. As you have noticed, QMap only extracts information from the current window display. This is called window processing. In other words, only the pixels within the window display are compared with all selected sample points. If you want to process the entire image, you need to zoom out so the entire image is shown on your window display. Now, by using window processing, we will attempt to use sample points from the trail of trees, which are points 11 to 20, to extract type A trees from the mountains. Let's do it now. The results seem to be quite good, as it is very close to previously extracted type A trees. Therefore, we can conclude that the trail of trees located outside of the mountain area are the same type as the ones on the mountains. Next, let's try and extract different types of cropland in the same image. Let's move to the middle part of the image. Let's assume this light-colored cropland as type B cropland. Again, this is not a professional definition or assumption. This is just for the sake of this demonstration. Now let's select some type B cropland sample points. Again, we can zoom in. Let's click the test button and see what that brings us. Well, it is quite satisfactory. By visual inspection, we can tell that most of the light-colored cropland is extracted. Same as before, let's reconfirm the extraction result by using the same sample points and perform window processing at another location. Let's move the display to the right side of the image and press test again. As you can see, light-colored cropland, which is type B, is also effectively extracted at the right side of the river, while the darker colored cropland is not extracted, such as here. So we can say, by visual confirmation, the extraction result is accurate. At this point, we can also isolate our extraction result by using no background information extraction presentation mode to better demonstrate the outcome. As you can see, it's a clear representation of the light-colored type B cropland. In this mode, there is not much disturbance from other sources. In conclusion, from today's exercise, we can tell that QMap is able to identify different types from the same subject and extract them out accordingly. This is especially useful when a lot of types of one subject, such as cropland, forest, buildings, different water bodies, coexist in the same image. Well, hope you enjoyed today's video. Thank you again for tuning in. See you in the next episode.